This is the introduction to our new PowerCell energy converter. It's not a perpetual motion machine. What it is an energy conversion machine, and it works fantastic. The cells are the same cells that I've been using for nearly 3 years now, only this is probably, I've probably gone through 12 to 15 different iterations of these cells, improving them a little bit each time. These cells are 12 inches square, which is 144 square inches. 24 of those square inches have been reserved for a dielectric only. So it's a dielectric insulator, and it acts as a capacitive layer. So when these chemically reactive cells start generating some electricity and the electrons collect on the plates, and these are not copper and zinc plates. This is not like anything else that you've seen anywhere on YouTube or probably anywhere else for that matter. But they're special alloys. They're not cheap. They're expensive, unfortunately, but they do the job, and that's the thing that I wanted. I wanted something that would last for decades, and these absolutely will. So we've got a semi-solid electrolyte in there, and there is a redox reaction that's spontaneous, that's happening all the time, and then that charge is polarizing that dielectric layer and it's charging it up just like a capacitor. So it's interesting because it's like a primary battery of sorts and a capacitor combined. But this primary battery isn't one that you're going to throw away in 2 weeks or 2 months or 2 years' time. This is a primary battery that's going to last you for a long, long time. So it's very interesting the way it works. These are nylon rods that run all the way through, and there's a nylon nut. So there's no conductive material that connects these cells, because these cells are in series, as you can see by the connectors up here and down here. They're all in series. It makes 21 volts, and I'm going to show you that later as we run a load, which would be a continuous load off just nothing but the cells themselves, just to prove that yes, they can run a load. It can be a motor, it can be lights, whatever it is, as long as it is within the threshold of the power that these can output on a spontaneous and continuous level. And that's what I'm going to show you. It goes from electrochemical and capacitive to electrostatic, which is all capacitive, and then it goes from there to electromagnetic. The electromagnetic runs through the circuitry, which is all digital now, and then comes on the output for charging. Let's just start it up real quickly and let you watch it start up slowly. It's pulling 16.2, which these are rated as 16.2 volts. They're able to deliver all kinds of current. I mean, the current delivery is amazing, but I keep it low because what I want to do is keep it close to what the cells can produce spontaneously. This unit comes pre-built, and you get these cables, and the cables plug in right here, right there, like that. Boom. You can use these clips here to go right onto a battery. What I would suggest is maybe even better, just cut these off, strip the wire, and go right into an MPPT charge controller. From this to the charge controller. That way, if you pull a heavy load on these capacitors, this one here and the one in the back, you will be discharging more at some point than these cells can produce spontaneously at a constant level. So I'm just telling you that right up front, that if you pull a really heavy load on these, you will pull these down. You're not going to kill the cells. You're never going to kill these darn cells. These cells, these cells are like unkillable. I swear, I've done everything you can imagine to try to destroy these cells, and they just keep on producing energy and coming back. I mean, what is up with that? It's really amazing. It's set on a very low level, and it's producing 28 volts. You can turn it down lower than that and produce, well, actually, no, that's a pretty good level for charging 24 volt system. You just adjust it so you get this thing at about 32 volts, which would be about 16 volts per battery on a 24 volt system, which is if you were going directly to batteries with these cables. I would suggest going through an MPPT. That way, when you start extracting or start discharging these two heavy capacitors, and it gets to a point where the cells can't keep up with recharging the capacitors at the same level that you are discharging them, then your power output, your watts, are going to drop, and they're going to drop and drop. And as they drop, the MPPT will take charge, and it will maximize the charge level at whatever you're feeding into it at the time. So it just makes sense to go that route. So I just want to tell you that up front. Now, also, this machine will produce nearly 100 volts. This 32 volts, 33 volts that you see right here on the meter right now, and then of course there's no power output, there's no current showing and no power output in watts. It also stores the watt hours too. I've been testing this, I got 9 watt hours. You can easily press this button right here, and if you hold it for a long enough time, you can access a menu that just clears this back to 0 if you want to do that. But right now I just pressed it one time, and it turns off the light for the LCD. Or if you want to conserve a little bit of energy, you can do that. Or just keep it on all the time. I don't care. Whatever you want to do. But it's easier to see when it's lit, but you can see it pretty well when it's not lit too. So it's one of your preferences. So anyway, that's what that does. Again, you've seen the two capacitors. Here's the back side of the thing. I got it on the little turntable here. So you can see this thing spinning, and we got a bunch of spaghetti there. And the thing about this is, the reason that I've got this so that it's not a kit and it comes in a pre-assembled mode is because this is a voltage multiplier circuit here, where I'm using these 3 bridge rectifiers and a combination of the coils to feed into it so that you can get up close to 100 volts. It easily can hit 90 volts, well, more than 90 volts. Each one of these really is about 32 volts, which is going to give you, let's say, the 96 volts. All right, 96 volts from all these 3 in series. But if you do 96 volts, these super caps here on the control panel are what power all the instrumentation, all the digital stuff. So they're 5.5 volts each, which is 27.5 volts overall. If you exceed that, these are connected to just this top bridge rectifier. Okay, if that's 32 volts and you can only load these up with 27.5, you've overloaded the supercaps, you're going to shorten their life. That's stupid. Don't do that. So if you keep it at 65 volts of output or less, you're well within the threshold of the top side of what these caps can safely do for, who knows, a million charges or 500,000 charges and discharges, whatever. These are Panasonic. These are pretty nice super caps. So these will go a million cycles in the Maxwell, no problem. So this will last you for years and years and years. So that's what we got, and this voltage multiplier is an interesting thing. So if you've got a 24 volt system, fine. If you got a 36 volt, fine. 48 volt, fine. It is an energy converter, again, going from electrochemical with a little bit of electrostatic into fully electrostatic, right here, into electromagnetic, and the output. Okay, this is just a quick demonstration to show you that the cells can run a meaningful load nonstop by themselves. Now what we're going to do here is use this motor. This is about a 2 or 3 pound motor. It's pretty hefty. It's not in like a toy drone motor or anything like that. It's a pretty strong motor. It runs about 1500 RPM off of 12 volts. So we're going to use this AGM battery, and it's fully charged. So let's take a look. If you see on the meter, it's 13.03 volts, fully charged AGM. Now what we're going to do is just show you how much current this draws. You know what the voltage is, so I got to hold this thing because it's got some torque. There we go. Alright, now it looks like it's spinning at about 10 RPM, but it's actually doing about 1500 RPM. It's the frame rate of the camera that screws it all up. I put a piece of tape on the end to try to help that, but You can see that, you can hear that. I mean, I can't put my finger on it because you can't stop it. It's a pretty strong motor. But anyway, that's the motor, and you can see here that it is drawing just under, it's just under 200 milliamps. All right, so about 13 volts. It's probably pulled down to about 12.8 or 12.9 under load, but at 200 milliamps. That's what the 12 volt battery, the AGM battery will do, and we want to look at the comparison of the cells versus this. I wanted to show you this part first. Now we'll run it off of cells only. I'm all set up here. This is the gray wire that goes to the motor. That's the negative, and you can see it up here. The red one goes into the meter, comes out of the meter actually. The green one, as you can see, goes up to the positive connection, which I've already connected up here. And this is the only other wire connected to the positive, and it's disconnected here, which feeds to the two capacitors, so there's nothing connected there. And then of course this is the negative that's been disconnected, so these cells are open, nothing connected to it. The only thing that's going to be connected to it is this gray wire going directly to the motor. You can see the ammeter, the comparison of what it does against to what we saw with the 12 volt AGM. Okay, so I'll clip the negative onto the post here so I can have hands free. All right, and let's check the positive up here. And we have 20.86 volts. So it's just under 21 volts, and that's typical for these 12 cells. I'm just going to connect this, and you can watch the motor start up. Okay. All right, it still looks like it's running very, very slow, but it's not. Let's see. Still doing 1500 RPM, and if you notice on the ammeter, wrong way, there we go. We are still pulling 200 milliamps, just like the 12 volt AGM battery lead acid was doing. Here's the connection again. Nothing else connected. This is loose. This is the only thing connected to the negative, and that's the only thing connected to the positive right here, this green one. This is again loose. So that's what the cells alone will do, and it will run like this, well, pretty much continuous. And just wanted you to see that it will handle a load. Now, of course, it'll do LED lights too. I mean, it doesn't have to be a motor. A motor takes quite a bit extra. I mean, really, well, it's not that bad. I mean, you can see 13 volts or 12.8 volts at 200 milliamps. It's not that many watts, but it's a pretty substantial motor. I mean, on the other hand, it's like I said, it's not a toy. So it'll run like this, and it'll just run and run and run. So if you like alternative energy experimental equipment, you can get prices, shipping, anything you want. Come see us at quantummagnetics.com. See you there.